if I say the inner shell has a charge of, let's say, plus 3Q. The outer shell has a net charge of, let's say, plus 5Q. That means the whole shell in its entirety, if I already put a Gaussian surface around it, the shell, the whole shell would have that charge. Huh?
You had told me I would have found it so fast.
Doesn't matter, I just showed you. One, then on the quiz. Depending on the, if it's negative, it's the same thing. Now, with charge, again, it's a thin shell. So, so on the inside of the shell, let's start with the inside one first. If this shell has a total charge of 3Q, where does all of that charge go? To the outer, it wants to get as far away from it as possible, right?
Mm-hmm.
So that means that there is plus 3Q on the outside of the shell. On the outside. So if you want to draw a surface inside of this thin layer, the charge enclosed will be 0. The charge on the inside of this is 0. So all the charge goes to the farthest point away on that surface. So if I enclose inside the shell, how much charge is enclosed?
0.
0, which means the electric field is 0. What if I take and make a surface inside the shell? How much charge is enclosed? 0. So the electric field inside the shell would be 0. Now, if I go outside the first layer, the charge enclosed would be
3.
3Q. So K, E would equal K times 3Q over R squared. Depending on where you are. Now, this is where people, part of this is probably my fault. Again, I own it if it's my fault. I don't know if I did explain this the right way or I need to explain it differently. If the charge on the outside of this is 3Q, right? The net charge on the outside one has to be 5Q. So the total charge on this entire ring, this entire shell is 5Q. So what would be the charge on the inside part of this?
2.
Why would it be negative 3? If you put charges on this shell here, what are some of the charges? Some of them, they're going to separate, right? Some of the charges are going to go which way? Towards the positive. So I now have an area of 0, an area of 3Q, positive. So then I have 2 more layers. Well, this entire layer is 5Q, but this inside layer is negative 3Q. The outside layer has to be 8Q. What's 8 minus 3? 5. Question?
Can you explain one more time why it's negative?
This charge in here is going to separate.
Okay.
The negatives are going to go towards here. The positives are going to go the opposite way. Like charges attract, opposite charges repel. I'm sorry, opposite charges attract, like charges repel. So this bottom layer on this second shell, which was, this is the A, this is the B, this is the C, this is the D, this one is going to match with this. Just the opposite side. And then the rest of it is going to go on the outside of it to get to the 5Q. So if I draw a Gaussian surface on the inside of here, the net charge is 0. 3 minus 3 is 0. If I put a Gaussian surface all the way around, the net charge would be 5. So E would equal K 5Q over R squared, or E would equal So the only time you have an electric field is outside of this one or outside the whole thing.
Thanks for sending that to me, by the way.
Now, what happens if it was negative? Now, this doesn't change. Let's say it's negative 5Q. This doesn't change. This would change to what? What is it? Negative 2.
Change that to -5.
So charge will separate. Again, I don't know if I didn't explain. Obviously, I didn't explain it based on that. Right? Does that make sense? When charge separates on shells, they're going to separate so that the charges will attract or charges will repel. All right.
However,
Yeah.
so, so if the charge separates, why is the inside of the first layer 0 and then the second layer?
Because
separate?
if 3 protons are here, it's going to attract 3 electrons here. 3 attracts 3. So the net still has to be 5 on that outer layer. Look what I had wrong. The net has to be +5. So if this is -3, this has to be +8 to balance the -5.